So our final step is to add all our partial quotients up. So we have to add up 2 plus 1 and 2/4 plus 1/3 plus 3/12. So if we're looking at our denominators here, they're not the same. So remember, when adding and subtracting fractions, we cannot add them unless they have the same denominator. Well, if we're looking, can't we multiply 4 and 3 to come up with 12 using the QCD method? And this is already 12, so we wouldn't have to change this one. So we would just have to do this one by 3, and then multiply 1/3 with 4. But whatever you do to the denominator, you must do to your numerator. So I have to do times 3 here, and times 4 here. So then I could rewrite it. I have 2 plus 1 and 6/12. Can't forget that whole number. Plus 4/12 would be what 1/3 turns into. Plus 3/12. Okay, so then if I look at this, I have 2 plus 1 gives me 3 for my whole numbers. 6/12 plus 4/12 is 10/12. And then 10/12 plus 3/12 is 13/12. So my answer would be 3 and 13/12. Or could we simplify that and make it 4 and 1/12? So my answer for 1 and 3/4 times 2 and 1/3 is 4 and 1/12. Look how much work it took to multiply using partial products to multiply mixed numbers. So guys, I do not want to see your papers blank. There should be your partial products listed. You have to find a common denominator when you're adding them, and then rewrite them with the common denominator before adding them. So there should be a lot of work. I know that the common misunderstanding when multiplying mixed numbers is you just want to do 1 times 2 and 3/4 times 1/3. But you have to make sure you're multiplying this whole mixed number with this whole mixed number. So that's why it's important that we use area models to multiply mixed numbers. Let's look at setting up another one. So if I had to multiply 3 and 2/5 times 5 and 1/3, I would want to set up an area model. So the first thing I would do is draw a box, and I'm going to put 3 and 2/5 on top. So 3 and 2/5, and they have to go together. You cannot mix up your fractions. And then draw your line. And then your second factor is 5 and 1/3. So you're going to put your 5 on the side vertically over here, and then 1/3. And again, draw a line splitting that up. Okay, so notice 3 and 2/5 is my factor. That's what's on top. 5 and 1/3 is my second factor. That's what's on the side. Okay, so that's what you need to make sure you're doing. If you mix them up and put 3 and 1/3 instead, and 5 2/5 instead, you will get the completely wrong answer. So it's very important to just get in the habit of putting your first factor on top, your second factor on the side. So then again, we're going to have to come over here. Let's try to use the text box and see if it's easier. Not as easy. Well, we'll just use the pen. So again, 3 times 5 is my first factor. 2/5 times 5 is my second box. This box down here would be 3 times 1/3. And then your final box here is 2/5 times 1/3. So then again, 3 times 5 is 15. We have 2/5 times 5. We know that this 5 is really over 1. So 2 times 5 is 10. 5 times 1 is 5. So I get 10/5, but I could also call that 2, right? Wouldn't that be easier to just call it 2 wholes? So let's change that to 2. Then I have 3 times 1/3, which is 3 over 3, or I could call that 1, right? That's the same thing. 3 over 3 is the same thing as 1. And then here I have 2/5 times 1/3, so then that gives me 2 over 15. Well, this one is pretty easy to add up. Since I simplified here and here, I don't have to find a common denominator. I just have to add 15 plus 2 plus 1 plus 2/15. So in this case, we did not have to find a common denominator, so not as much work as the last one. So 15 plus 2 plus 1 gives me 18 and 2/15. So my answer for 3 2/5 times 5 1/3 is 18 and 2/15. Okay, so guys, I would like you to go ahead and open up your math journal. And if you need to rewatch this video to see how to set up your partial products and area model, then go ahead and do it. Okay? But make sure that you're showing all your partial products and area model for every problem.